Okay, part two. Example two, write an equation that matches each exponential function. This is kind of just a weird sort of almost backwards question where they give us some stuff and we want to come up with the equation, where yesterday we were given the equation and then asked for the stuff. So a bunch of stuff here. What I would do is draw a graph and then a sketch, and then we can have an idea of what's going on here. The y-intercept is 4. Asymptote at y equals 1, so this doesn't have to be to scale. There's y equals 1, and I see the range is above that, and it's increasing. Well, it means it's going like this, right? There, and so now, how do I come up with an equation? I got to think about this. Well, notice that this is 3 units off of the asymptote. So that might be, I might be thinking about a stretch of 3 perhaps. And so how would I get the rest? Well, what's the base? It doesn't really matter. I don't think. We could try any base with a stretch of 3. We could try something like, you know, stretch of 3, base is 2 to the exponent x, and then that we know the y the asymptote of y equals 1, rather. Sorry about that, is plus 1, up 1. So does this make sense? Is this going to give me a y-intercept of 4? Well, check it. X equals 0 is going to be 3 times 2 to the exponent 0 plus 1. That's going to be 1. Yep, that works. So this graph works. Is this the only one that works? As it turns out, when we have this stretch of 3, it doesn't really matter what the base is, as long as it's got a positive, or sorry, an exponential growth function, that the stretch will make it work out. So this one would work as well. Right? Because again, x is 0, going to make this 1. 3 times 1 is 3 plus 1, and that one works as well. And actually, there's lots of ones that do work here. For the second one, notice I've got a little hint right here. So x is minus 1, y is 3, and it's a decay function. Well, that gives me a hint that the base is probably a third, isn't it? So when this is the function, and in fact this one works, I can see that if I erase it, because I scribbled over it, it looks like probably, since this is x is, or y is 3 here, is each tick is 3, so that's 1 unstretched. That looks like the right function. Okay. And those are kind of neat problems, backwards graph problems. This is more like a real life type problem where we've got a pickup truck, Uncle Ferd's fraud pickup. That's a beauty. That's a beaut, that one. Given by the equation, there's the equation, and we see that the base is less than 1, so this is a decay function, isn't it? This is a going downhill one, even though we're not asked to graph it. T is the number of years since 1992. It must have been new in 1992, and again, that's a beaut. And V is the value in thousands of dollars. So V is the value in thousands of dollars. So if we explain the parts of the model, this is kind of like the stretch. This is what it started as, right? That's the y-intercept. 14 is the initial value. And so, because it's in thousands, Uncle Ferd paid $14,000 for that thing in 1992. And then what does the base mean? The 0.78 is the base. It means that it's a decay function, but how much the base shows it's a decay, but by how much? It's not like it's decaying by 78% every year. Remember, if it stayed equal, so if it was always worth $14,000 over time, that this base would be 100%. It retains 100% of its value. And in fact, the two models that you may have seen from grade 11 is this sort of thing. Well, Y or V or A for amount, however you think of it. If this is above 100% or 1, that's growth. Again, the base is more than 1. But if it's this, 1 minus I, that's decay. And this I is the percent that it's going up and down. So what we've got to do is figure out how much percent that's gone down from 100. And hopefully you've figured out already that it's 22%. So the truck, the decay amount is 22% a year. When will the truck be worth less than $1,000? Well, notice, first of all, there's a trap here. That V is 1 because it's in thousands of dollars. So I want to know when the value is 1, where the right-hand side is this equation, and I want to find T. So there's a couple of methods of doing this. And I'm just going to start us with this one because then I'm going to do the one that I like the best. You could use your scientific calculator. So this is guess and improve. Right, so you guess, maybe it'll take 10 years. And then you fire that into a calculator and see how close to 1 you get. Well, let's see. If I go 14 times 0.78 to the exponent 10, I get 1.16. So it's still worth over $1,000. So then I want to go, well, maybe 12 years. And then I adjust my other guesses after that. What I'm going to do, though, and I'm going to say ... there. I'm not going to finish this way. Method 2 is I'm going to use the graphing calculator, the TI-83 intersect. All right, so we have the stuff left over in our graphing calculator from before, right? That we solved that before. So I got to get rid of that, and I'm going to put the right-hand side in there. 14 times 0.7878 to the exponent t, well, x, that's the same thing, and when it's going to be 1. Now, notice for my window settings, I've got to be smart about this. It's a decay function, and I just saw with one calculation it's going to be more than 3.5 years, so I might go up to 15 years or something like that. As far as the output, I know it starts at 14, right? Maybe I don't need any negative values. It's nice to leave some in there so I can see my axis. So I'm going to start at $15,000, and then I should hopefully see these two graphs cross when I press graph. And if I don't, I'll go back and I'll fix my window settings again. So and there's my, right there. So I could count, right? I could count, but I'm just going to use my second function calc intersect value, or intersect feature, first curve and second curve, scroll over to the guess, and then bam, it's going to give it to me 10.6 years. So I'm going to say x equals 10.6 years, about. And I'll write a decent sentence in a second. In fact, what I'm going to do here is, oops, that was about, sorry. I'm going to take a screenshot and paste that in there just so I can do this later. You should, on yours, draw a sketch of this graph. Please and thank you. And we can see the intersection there. And I'll just say it will take 10.6 years. So notice there's your work, is that you use the TI-83 intersect feature and a sketch of your graph showing the intersection point. That's fast. Okay? And we're going to be solving some of these problems later in the chapter too, because they're so fun. That's it.